for joining us for Hello Robot, Do You Speak My Language? And it's going to be a fairly interactive session. It's going to be one of those where we are here to have fun. And as our abstract said, you don't need any advanced degrees in any of the educational fields to A, have fun, B, do something cool with machine learning, and 3, build robots. And we'll first get into the agenda. We'll start out with introducing each other and introducing ourselves rather, and go through our backgrounds and what is our motivation for the talk. Then Breandan will go take us through the introduction to speech recognition, how it has evolved, how is it right now. Then I'll be doing some live demos, coding one of the Lego Mindstorms, which is out here, then doing some fun activities with the drone, which is put out there. And with that, to begin with, you want to introduce yourself?
I'm Breandan Considine, as Nikhil mentioned, and I'm interested in machine learning and speech recognition. I graduated about 5 years ago in computer science, and since then I've been working on developer tools and checking out cool things in speech recognition. My favorite thing to do is to learn about your application and get a feel for what applications are interesting to you and how we can apply machine learning to them. So I'm available online if you want to reach out to me. And I do hope you'll come to some of our sessions. Nikhil has a few sessions this week, as well as mine, about machine learning and Goldman Sachs collections, Eclipse collections. So thanks very much.
So I'm Nikhil Nanivadekar. Originally, I'm a mechanical engineer. So you guys must be thinking, what is a mechanical engineer doing here at a software conference? So I actually write code for a living. I'm a software developer at Goldman Sachs. I'm a vice president in their technology division out in Salt Lake City. I'm originally from Pune. I did my bachelor's from MIT Pune or Pune University, and then went for my master's at the University of Utah, which is in Salt Lake City. There, my major was robotics and controls. Until I joined Goldman back in 2012, I had not written like a single line of Java code. And then from that, currently I'm the project lead of Eclipse Collections. It's one of our many open source projects out there. It's in the Eclipse Foundation. It's a feature-rich collections framework, and a slight shameless plug. I'm going to be comparing multiple collection frameworks tomorrow in the afternoon. There's a session called as collections.compare. Feel free to attend. It's a very good and nice and informative session. Tomorrow morning, like my background is as a mechanical engineer and with a specialization in robotics. I like to, do demos and build robots and do some cool things as a passion. And I'm going to be presenting on robots for the kids and all of us. And it's one of the many interactive sessions that I have developed. And where we'll be doing a live coding demo. We'll be doing some live coding today as well. We'll be doing some live coding demo tomorrow, solving some motion planning problems. And then we'll be tweeting stuff to the robots. So make sure you attend tomorrow's talk as well. With that, I'm going to hand it over to Breandan to take us through the introducing speech recognition and the advancements in it.
Thanks, Nikhil. So when we're going over the session, Nikhil, we were thinking, how could we take some of our interests and put them together? And robotics is one great way to demonstrate some applications of machine learning. And we thought, well, since I did a little work with speech recognition, and Nikhil is familiar with robots, we thought we'd put that together and see if we could get a robot to move around and respond to our voice. So that was our goal. And we'll show you how we did a few of these things, and particularly using an open source framework for Java called CMU Sphinx. But before we get into that, let's talk about speech recognition and how it's developed over the last few years. Speech is one of those things that's extremely important for us in our daily lives. And since a very young age, you've probably used speech to interact and communicate with people around you. And this is something that is very natural for us to do. So how could we take this, this method of interaction and move it into the digital world so we can interact with robots and lots of smart devices, IoT devices and things like that. And for many years, we really didn't figure out how to do this well. Speech was something that a child could do, but machines had a very difficult time interpreting speech and using that as a command and control interface. So as we're thinking about this, we're thinking, well, we have some tools available right now that do the job well enough. And particularly for our task, which is not just recognition of the entire language, but a small subset of commands, then we could use some tools very easily to reliably interpret what we're saying. So one of the major advances in the last few years has been in speech recognition. And they've applied this to lots of different domains. But probably the most obvious one for you would be a mobile device. So maybe you can use this while you're driving on your mobile device to type something, a quick reply message to your friend. And this has gotten dramatically better in the last few years, particularly at adapting to individual speakers and to dialects of a language. So just in the last few years, we've seen enormous improvements in word recognition error. So it's gone down over time. And this is just the last few years. Till this year, we're just crossing sort of a threshold where speech recognition on a computer or a device, a mobile device, is approaching the accuracy of someone who's trained as a transcriber. So this is something where we'll be able to use computers to replace some of these jobs, maybe for transcription and interpretation. So how did we get to that point? Well, researchers attribute this to three primary things. One is the evolution of enormous amounts of data and availability of that for training. And this has spurred an enormous amount of research in speech, as well as lots of different machine learning areas. We've gotten much faster hardware, so we've been able to parallelize a lot of the algorithms we already have to make it extremely fast. And finally, and I think this is probably one of the largest improvements, has been we finally really cracked how to train these very well. So we're able to use smarter algorithms like deep neural nets and some of the techniques that have developed in machine learning, and applying these into speech to get much better. So that's a kind of a short overview of state-of-the-art speech recognition. What we'll be using is something that's a little bit simpler, but it gets the job done for our purposes just as well. And that's traditional ASR, which is a little bit more complicated to set up, but it works very reliably for small vocabulary grammars, and this is what we have. For general transcription, the error rates are considerably higher. So if you're trying to recognize a grammar or a language that has thousands of words, then many of those words will be similar, and the error rates that you'll get are much higher, particularly for accents. So if for a particular accent, like maybe a British English accent or an accent that's not well represented in a training set, you can get very high error rates. So this is something probably you're familiar with. Maybe a few years ago, this was a huge problem in speech recognition, and particularly for our task, which is using some offline speech recognition that's pre-trained for a US English accent. This will be, maybe we'll be able to see the difference when I demonstrate with my voice and with Nikhil's. But in any case, this is something that you need to take into consideration. So maybe if you're training a model from scratch, which we won't go over, but if you are, then you want to incorporate data from a training set that's representative of the users who are using the application in production. So particularly for this case, you want to use an accent that's from maybe in India or Karnataka, maybe. There's an accent here or a language here that you could train it on. We'll be using US English. So in any case, if we were to use this, were to use the state-of-the-art, we'd have to use to train this for a long time. This takes a lot of expertise and a lot of fine-tuning. So the open source frameworks that are available to do this are are perfectly able, you can use them, but it takes a lot more work to configure and set up. So we'll be using CMU Sphinx, which is one type of early speech recognition that's particularly well suited for Java applications, and it has a great API that you can use. It's much easier to set up. So let's take a look at just how to do this. We want to make this really as clear and simple as possible. And so I'm going to demonstrate how to recognize some simple speech in just a few lines of code using this framework called CMU Sphinx. And then we'll dive into how to configure this and set it up afterwards. So hopefully you'll see that it's not too complicated when you're just getting started. The hello world for this framework is less than like 15 lines.
It's not mirroring for some reason.
Let's see.
Can you run it with that?
Should work. Is this the one?
No.
It's the Hello Robot Lego demo or Hello Robot?
The Hello Robot one.
Okay. I don't think so. Is it all right if I close this one?
Which one?
The Lego run?
I need that.
Okay, let me see if I can.
So it's out there.
Yeah, I see that. Oh, okay. So it's.
Yeah, it's not
Oh, can
mirroring.
we mirror this? Let's see. Display settings.
Sorry, technology issues.
To extend, duplicate, right? Let's try that. Okay, good.
No, it doesn't look that good because the resolution.
Is that better? Can you see this in the back row?
Can you guys see at the back?
Okay, if I can make this a little bit bigger.
Yeah.
So this is just about as big as it gets without getting off the screen.
Looks good?
Okay,
Yeah.
good stuff. All right, let's get started. So in this framework, CMU Sphinx, we're going to have a configuration. And a configuration is just kind of a POJO that holds some data. So we'll create one of these. And we'll go ahead and set it up. So we're going to introduce something called an acoustic model. An acoustic model it models the smallest phonemes in your language, so the smallest kind of acoustic building blocks of the language. And we'll need to pass it in as a file. So this file is located in a particular resource, in a directory, and I've hard-coded that as a string. So the acoustic model path is just here, and this is located inside of our project directory under the resources here. And then once we have that, we're going to need to add a dictionary. The dictionary is also hard-coded as a string, conveniently. Let's set this up. And we're going to need to pass it. A dictionary just contains lots of words we're using. In our case, it's a word list of English language words. And we're going to finally add a grammar. So a grammar in our case, is a fixed grammar. There's going to recognize like a very small set of phrases. And this is also just a path. We're going to need to tell it to use that grammar initially. So since it has an acoustic model and a dictionary, we're going to need to confine that dictionary just to the words that are inside of our grammar. So we'll do that by saying set use grammar to true. Finally, we're going to tell it to use a particular grammar grammar file. So we can have lots of different grammar files, and these will represent maybe context in our application. So we have a set of command grammars that will control our robot, and the one I'm going to use is a conversation grammar. It just has some simple phrases that we'll recognize. And here, there's just two to make it as simple as possible. set grammar name, and we're going to say this is the conversation grammar, since there's more than one in this directory. Okay, so now that we have this, we're going to need two things. One is something to synthesize speech, and the other is something to recognize speech. And this is all sort of built into the framework. So to recognize speech, we'll use a live speech recognizer, which will read off the direct microphone line, and it will produce some results, and we'll pull that from the object. So we'll say here we have a live speech recognizer. We're going to pass this the configuration that we just set up. And now we're going to introduce this as a local variable. So call it a recognizer. And we want to tell this to start recognition. So
do you want to minimize the project?
Yep. Let's see. Okay. So maybe you can see this whole thing here, but it's put this in screen. And we're going to add a pre-configured service that I've set up called the TTS service. This allows us to speak some phrases out of the microphone. And in our case, this is just a few extra lines, but I didn't want to write this. So I'm just going to say TTS service. We're going to get an instance. This is a singleton. And we're going to introduce this as a local variable so we can access this later. And this has one method that we'll use called say. We'll say, in our case, we're going to do a little joke. So we'll say knock, knock. And this should speak it out of the microphone. And you should be able to hear this if we've done this correctly. OK, so as I mentioned, we're going to have to pull the results off of this recognizer. So what we'll do is we'll say, here it doesn't really matter. We'll just say, while this is true, we're going to listen for results. Typically what you do is set this up as a callback so that you'd be able to process these in another thread. But this is fine. We can just do it like this for now. So while this is true, we're going to say recognizer dot get result. And this is going to be returned to us as a speech result. The speech result is another POJO that contains, oops. Let's do that one more time. These results. And this will contain some hypothesis, or a bunch of hypotheses. For our particular model, we have two phrases, right? So the first one is usually the one that we want. If you need more than one, so it'll have more than one hypothesis, then you can get n best and pass it in as an integer. Here we'll just get the hypothesis, and again, introduce a variable here. And just for testing purposes, we'll say, well, let's print this out. Hypothesis. Right. So what this will do is it will block on a result, so it won't get to this line until it actually reads the result from the microphone. And it will return this, and it will print this out. And then let's just add some logic here. So in our command grammar, in our conversation grammar, we have these two phrases. Who's there, and let us who. So this is what I'll say. And these will be passed to us as a string. So if the hypothesis equals, say, who's there, then let's say lettuce. What did we call our instance? Okay, instance. And finally, if the result's else, if it's something else, we're going to say right, okay, simple enough. And if I've done this correctly, I should be able to run this, and it will say my joke. So are there any questions about this while it's starting up? Oh, looks like we'll need to, could not find the path that's specified. Let's see. So maybe we didn't tell it the right path. The grammar path. What's that? Could you?
Yeah, it should be set grammar path.
Set grammar. Ah, good catch. Thank you very much. Let's try that time. And I think it might have said it, but I don't know if this output is loud enough. But let's see, who's there? Who's there?
Is it muted?
Okay. Who is there? If we did this correctly, it would have printed that out beneath there. Let's try it one more time.
Skip it and
All right.
take it forward.
Let's, oh, here we go. So it looks like it's recognizing something. Who is there? So for some reason it isn't speaking it, but it's recognizing it. So that's a start. Who is there? So here we recognize it off of the microphone. But is there another microphone sound controller? Okay. So right now we're not getting the result from the speaker, but we're getting the input from the microphone. So that's a start. If you want to do synthesis, then you'll need some form of audio output, but it isn't working right now, which would give us our joke. So let's move on. So this is what we did just now. We set it up so that we have all of these dependencies. Our dependencies are just Maven dependencies. So we'll introduce just two dependencies for Sphinx to do speech recognition. And then after that, we'll set up the grammar path as we mentioned. This grammar is specified as a JSpeech grammar format file. So this will take in the file, and you'll specify this as just some tags. Initially, these will be just an OR. So the vertical bar represents some commands. And here, you'll notice that this takes the form of a tree. So size can be expanded to this node, which will be a leaf node. Here it's small, medium, or large. And color might be different colors. And some other actions here. So this is also another JSpeech grammar file. And this specifies an English grammar for numbers. You'll see here that this is the root node, expands to just hundreds, tens, teens, and ones. And then we'll expand these later on to different possibilities of words. And we'll say that these are all equally likely. But if you want to add probabilities, then you can do that. These are probabilities that should be normalized to a maximum value. And as we mentioned, we'll set up the configuration and provide it a recognizer. In our implementation, we have a custom speech recognizer, which will allow us to read directly from the microphone and do things with the raw audio bits, like adjust for volume and things like that. But here, this is pre-configured, this live speech recognizer, inside of the platform to do live speech recognition. However, you can also use other ones for reading from a file and so forth. Like we mentioned, we'll just block in a recognition result and do something with the hypothesis. Does that make sense? Okay. Right, so for speech synthesis, we have a similar tool called MaryTTS. This is also open source. It's developed by a university somewhere in Germany. And they have lots of models for different languages, which you can download. And they'll speak something that sounds pretty robotic, but they're getting much better at doing speech synthesis, so it sounds much more natural now. But this framework allows you to do speech synthesis from a string to some sound. And we'll set it up inside of our speech synthesis service to just use some simple audio players. And this is pre-configured with our microphone if you use Windows or Mac. So you don't have to do any firmware hacking to get this compiled. It just works for me anyway. So with that, I'll leave it to Nikhil.
Thanks, Breandan. Breandan, sorry. And I apologize beforehand because I generally like to move around and give a presentation, but since I'm going to be doing live coding, I'm stuck at the podium. It's a fairly open forum, so if you guys have any questions or want to interrupt me for any, any feedback, just feel free to raise your hands and we'll end up chatting. Yeah. That's for you.
Yeah, sure. So I guess there's lots of different applications for it. One is to do typing. And this is one way to get a faster output. You can probably speak a lot faster than you can type. Another is like for disability, if it's assistance, assistive software, where you have somebody wants to use their ears and their voice, but they can't see very well, or if they have some mobility impairments, then this is one way to get input from that user. So I guess that's probably the main motivation for using it on your mobile device is to type, because it's a little tricky. From automation in what regard? So the question was, how different is it from automation? And is the main purpose for speech recognition just to do typing? So transcription, that sort of thing. So in what regard do you mean about automation? If you want
You can say, we'll repeat it.
What I'm asking is, like, whatever you showed me right now, right? This is my basic question.
Mm-hmm.
Today we hear about AI, right? Artificial intelligence, right?
Mm-hmm.
And if I was the developer doing something like this, right?
Mm-hmm.
So I would have thought this as a automation of, let us say, one of the process.
Mm-hmm.
So what is that key difference which will say this is not automation, this is AI, or is it an advanced level of automation only we call it as AI, right?
You will see it in a few minutes in the demo, and then you can answer your own question by telling me if these things can be totally automated, or it's something where you still need a human touch.
Okay, okay.
And you will see the reasons as well.
Sure.
Okay.
Thank you.
So that was kind of a nice, a filler, because I needed my robot to start. So thank you. How many of you have heard of Legos? Okay. So before we get into that, okay, I want to know, what do you define as a robot? What do you think is a robot? It's an audience participation, and I'll go on repeating whatever anyone says. I'm going to give the gentleman at the back a chance.
Basically, robot is a combination of sensors connected to each other to build a complete object.
Okay. I'll go on repeating, Simran. You don't have to run around.
Doing some actions on certain set of inputs.
Yep. I'll take one more, and then yeah. Let's take two more. Yeah.
Yeah. It moves.
Well, yeah. That's a very simplistic and
Yeah.
a real explanation.
Yeah.
It moves, and the last one at the back.
I think replacement of human intervention is called robot.
Okay. Yeah. Pretty much. So, okay. Fine. One more.
Thank you. So basically, it's a set of mechanical components that is capable of taking instructions and following accordingly.
You pretty much summed it up, and I'm going to trust my Wikipedia source because it's really authoritative.
I didn't Wikipedia.
So according to Wikipedia, a robot is a machine, especially one which is programmable by a computer, capable of carrying out a complex series of actions automatically. Now here I want to sort of highlight a few things. It should be programmable, okay? Then it should be capable of carrying out actions, okay? So these are the two things. And the next sentence is pretty much generic, which says robots can be guided by an external control device, or the control may be embedded within. And here we are going to see how it's an embedded control versus how it is, how you can have an external controlling factor to it. So this is a Lego Mindstorm. How many of you have heard of Legos? Okay, I had not till until a couple of years ago, I had not actually played with Legos, and because they are not that readily available in India, and I'm born and brought up in India. So back like a couple of years ago, one of my mentors from Goldman Sachs, he actually bought a Lego Mindstorm for me. It's a stock solution of Legos where you can actually build your robot, give it different forms and everything. It comes with its own. It comes with a couple of servo motors, a few color sensors, a few ultrasonic sensors, and a programmable module. And right now what we are going to do is we are going to program those robots, okay? And I'm going to use Java. Like I said, my academic background is not in computer science, and Java is the language which I started working with when I joined Goldman, and I'm comfortable with it. And Breandan can tell you that how much of a argument both of us had, because he wanted to use Kotlin, and I said, I don't want to learn a new thing right now. I don't have time for it. We'll go with Java. So he had to go back and redo all his work. I apologize for that, but it works now. So, all right, going back to this guy. So this. So this here is a Lego Mindstorm, and it has two servos. These are the pilots, which will make it go forward and backward. Then it has another servo out here, which will actually operate the gun, and it will shoot these pellets. And this is the microcontroller, which I'm going to program from here. And I can see that the IP address is 10.0.2.1, and you can see the Ev3 IP address. I've pre-programmed all of those things because I don't want to waste time out here for that. So now what I want to do is I want to I want to basically connect my laptop to the robot, and then, like someone said, it is something which moves, right? I believe it was you. It's something which moves. So we'll try to make it twitch. We'll try to make it move forward and backward. All right? So in order to do that, the first thing that I need is I need to initialize the Ev3 controller, right? And the way I do it is, again, I've initialized all of those variables because in my finally block, I'm actually disconnecting them. And I'm not going to bother with showing you all of those details. But I'm here for the whole of the conference, so feel free to catch me anytime, and I'm pretty open to sit and discuss, and we can also do some hacking on these robots out here. Okay, so since I'm going to connect remotely to it, so this is the remote request Ev3, and it takes in a host, which is my Ev3 IP address. Okay. And then after that, the way I've connected is the two pilots are on A and B port, and the gun is on port C. So I'm just going to get those from the Ev3. And when I say get, basically I'm saying that, hey, I'm going to use these ports, so go ahead and connect it. And I'll take all of you guys through what exactly is this working, because you must be thinking, hey, it is just Java. Why is it connecting to that, and how is it going to make it work, right? So we'll go through that. Don't worry, trust me. I was in that place one day, so I know how you guys feel. And then I'm going to call it a pilot, because the pilot is something which will move both the motors synchronously, and then it will make it go forward and backward. All right. And create pilot, and it needs a wheel diameter. It needs a track width, and conveniently it's all out here. And then the left motor is A, and the right motor is B. Okay? And these are slightly important because you want it to go forward when you say forward. And generally what ends up happening is most of the time you end up switching that. So at that time you have two options. You either change the ports out there, or you can change your code to go the plus to the minus. Okay, it's easy that way. Then after that, I want to connect to the this is happening because I need to cast it. After this, I'm going to get the third servo, which is going to be used to shoot the pellets. And now, this one is a standalone motor. It does not need any synchronization with any other motor. So that's why I can just go and say that get me a remote request regulated motor. All right. So ev3.create regulated motor, port is C, and type is L. And then you need to make sure that since now this is non-synchronous, it's a regulated motor, you want to make sure, you want to control how fast it moves and at what acceleration it goes till that speed. All right, and since it's a gun, I want it to go like shoot the pellet really fast. So I'm going to keep it like a very high acceleration, like 500. Set speed, 800, all right. Now that I've initialized the whole robot, it is connected, okay? Let's see if it goes forward and backward, okay? So I'm going to just say EV3, sorry. So again, what I did was I ended up creating a common utils so that I can just take it forward and backward, and I don't have to, because the way you move this robot is you give it a command called as go forward, then you put a thread.sleep or a delay.msdelay. And then you basically sleep that thread for 1 second to like how much ever you want, and then you say pilot.stop. Like there are other ways to say that, hey, keep on going for 10 seconds, but this is the easiest that I've found. Okay, but all of that code, and if you see out here, that's what it is doing. It says pilot.forward, delay.msdelay, wait for a second, and then pilot.stop. Okay. Dot backward, and then pipe. Okay. So what it should do is it should go 1 second forward, 1 second back. And then generally there is more, like there's a difference in the torque. So if you think that, hey, if it goes 10 meters ahead, it should come 10 meters back. That's not how it happens in real life. Because trust me, physics always wins. And I'm just protecting my robot, otherwise it will fall down. All right, so let's see. Let's run it and see if it goes forward or not. Today, none of the demos want to work. Oh, it was the connection problem. I was like, this is embarrassing. It should just at least twitch, you know? Yeah. All right, so like I said, it just went forward, it came back, right? It's easy enough, it moved. So by someone's definition, it is a robot, all right? But that's not enough, right? Because there are only a few certain steps that you can pre-program and keep. You always want the human touch. And right now, I'm going to add the simplest human touch by saying, hey, get me a scanned, keep on scanning the console, and whatever you type, get it back. And in the interest of time, I have already pre-coded this. So it's nothing but a series of case statements. So let's import that. All right, let's run it. So it went forward, it went backward. Now it's waiting for my command. And you will see why I'm sort of taking this much time to do forward, to do such a simple thing. I should have just typed backward out there, but sorry. You guys are not really in a joking mood today. Like, it's a very serious audience. Like, these are all the jokes which generally people laugh at, but okay. Should I make it stop working and then you guys will laugh? Okay, that's fine. But okay, let's actually try to sound the gong, and that's like making the gun work. So if I just say sound, thank you, Breandan. But I'm here going to stop in the interest of time because I want you guys to see the drone. I know I've got like last 10 minutes remaining, and I saw a warning out there, and I want to leave it open for questions as well. So going to the drone, so you saw Breandan actually show us how the ASR service and the TTS service works. But to a gentleman's question out there where, hey, what exactly is automation? Okay, so we are going to see a real-life automation out here. And what I did was I basically built out a drop wizard application, and I called the services which he had written. And so I'm quickly going to demo how it is working. And oh, I've not started the drone as yet. Hold on. All right. This is just to show what exactly is underneath it, and then you guys can see how stuff is, joining both the sides. All right. So what I did was actually created, and I'm not going to take 100% of the credit. It was one of my friends and colleagues who helped me build this out. And it's sort of a gaming console. And this is my override console. Because to Breandan's point, if this guy does not understand what I'm saying, then I don't want it to go haywire. Okay? And that is the first disclaimer. So whoever is in the first rows, if you see that I'm not trying to get you, but that means the drone has gone off control, duck. I have the override switch. I'll end up using that, and then it will just turn off and it will land. Okay? Do not try to hold it because it really hurts. I've tried it. Okay? It hurts a lot, trust me. That is the first disclaimer. Second disclaimer is I know that drones are not supposed to be bought and imported in India, and I did have to go through a grueling customs screening and everything. And trust me, this is going to go back to the States with me, so it's not to be kept in India. And I'm saying this because I'm on camera, so I do not want any notices afterwards. But this is going back to the States with me. All right, now it goes through its own initialization process, and I should see the AR drone Wi-Fi out here. Okay, AR drone. And once I'm done connecting to this guy, I need to connect to its own IP address because okay.
So one of the things that was confusing to me at first was how we're connecting to the drone only supports one machine, one device. And the Wi-Fi is hosted on the drone itself. So as you saw, Nikhil is connecting to the Wi-Fi, and we'll have to...
Yeah, but I've got no idea why right now the Wi-Fi is not working. So.
So there's options to get the code, all of the code, running on the drone. But we had a problem, which is, well, if the drone has some kind of processor in it, some sort of CPU, and we could do speech recognition on the drone itself, it would create an enormous amount of noise. So we thought it best to do the speech recognition on the device, the laptop, and then use that to send the signal to the drone. However, a lot of drones now you can use with Raspberry Pi, for example. So we would be able to add a microphone if we had a robot, something that was quiet, and use that to directly command the robot, getting this to run on a low-power kind of mobile device. But for this particular example, the CMU Sphinx project needs a lot of resources, a lot of CPU and RAM. So there's a Pocket Sphinx, another build of Sphinx that will run on low-power mobile devices.
Okay. I don't know why my laptop suddenly decided to go into airplane mode. But so once I'm done connecting to this guy, I've got no idea why it's stuck out here. Yeah, it's safe. Okay, so
Can you control it using the interface from the browser, maybe?
yeah, no, I cannot because I need to connect to the.
Problem is with that.
All right, haha, okay. I don't know, for some reason right now my laptop seems to be really slow.
says here the drone could be pinged.
Yep. So. Good luck to me. Fly off. Fly off. Oh, the drone is not yet fully initialized. Fly off. Okay. Sorry guys, this was really embarrassing, but in the interest of time, if you guys have any questions, I'll make sure to fix the demo, and if you guys want to meet me outside, I'll definitely show it to you. But there's something wrong with the internet, and I'm not able to go in. Oh, right in time. Where's the IP address?
So maybe, is
Yeah.
anyone else connected to the drone maybe?
No. Has anyone by chance connected to my drone out here?
Because it's open, maybe it's unsecured and someone else is connected.
It shouldn't. But so, anyways, it's there's a Wi-Fi issue and my system is not functioning fine, and I got a 1-minute queue out there. But I promise you it does work, and I have videos to prove that. And we can definitely meet outside after I wrap it up, and I can show you the demos out there. And I'm going to be here tomorrow as well, so we can definitely get back tomorrow, and we can chat more about this. Thanks everyone for attending and spending your time. Have a happy kids.